The Knots Company welcomes you back to Focus on Automation, where we explore and celebrate advances that empower manufacturing. Welcome back to Focus on Automation. I'm your host, Todd Youngblood, and today we're going to take a deep dive into a technology that way too often gets ignored, in my humble opinion. It's something that's versatile, effective, efficient, inexpensive, all those things that we like to hear. And to help us understand at least a few of the many applications of this semi-secret technology, my guest today is the celebrated and famous pneumatic YouTube star, Dr. Vacuum. Doctor, thanks for joining us.
More than happy to, Todd.
Well, just to get us kicked off here, Dr. Vacuum, tell us a little bit about yourself.
Well, I'm a mechanical engineer with a little bit of knowledge in electronics. I come from a wide background of different opportunities in my time frame. I've worked in the machine tool industry. I've worked in the fiber optic industry. I've worked in the medical industry, the fire suppressant industry. So I have a wide range of experience that helps me make lots of decisions about certain types of applications.
God, well, you've certainly been around the block a few times, which is good to hear. I got to get into the question on the top of my mind is vacuum doesn't get the respect that it really deserves. Why is that?
Well, out in the industry, they seem to call it the black magic. And I think it's just that most of the engineers are so used to doing things mechanically.
Yep.
And so they seem to avoid the vacuum aspect of automation. Why that is, it's probably because the inexperience using vacuum in the industry.
Gosh, do you think it has anything to do with just hype? You know, I think particularly you hear so much about artificial intelligence and all the electronic advances. Is it just getting crowded out? Is it viewed as, an old, tired technology? It certainly is not.
That's a good question. I just don't think that people just have enough understanding about vacuum. I mean, vacuum has been around a very, very, very long time. However, in all the shows that I go to visit to see what's going on out in the industry, I found that about 7 years ago, 80% of the automation was mechanical.
Yeah.
And recently, it seems like that has totally turned around where 80% is now vacuum. So finally, I believe vacuum is starting to be recognized out in the automation industry.
Now, is that all because of your fame and the message you've been delivering out to the marketplace?
Let's hope I have a little bit to do with that, yes.
I asked that question with a smile on my face. But more seriously, why that reversal? I mean, that's dramatic from 80-20 to 20-80. That's a heck of a change.
Well, I think the biggest possible change is the expense of it. Mechanical grippers are expensive. If they need to be replaced, that expense is still pretty big. Whereas in vacuum, you very rarely have to replace the vacuum aspect of the application. You may have to change out vacuum cups here and there, but vacuum cups are very, very inexpensive, $10, $20.
Yeah. What do you think is causing it? Again, and it is a little bit of your influence and the knowledge that you're spreading around the industry, but what do you think is behind the resurgence?
I think the simplicity of your end-of-arm tooling, where you don't need as many components, it's easier to use, it's easier to change over, all those things that add cost are removed when you're using vacuum.
How about reliability?
Vacuum is incredibly reliable. I mean, you're using compressed air. And so for the most part, as long as your air compressor is running, your vacuum will always function.
Let's talk a little bit about applications. I just have this sense, and you tell me if I'm right or wrong about it, is that if I'm trying to solve some issue out in my plant floor or warehouse or wherever it may be, I think I need to be thinking about the potential of using vacuum as part of the solution I have to whatever problem it is. Talk about a couple of the applications where vacuum gets overlooked.
Well, I think it is overlooked in applications that are unusual. Maybe the product that's being picked in place has strange dimensions. Nothing's flat or smooth. It's, like say a bolt, because of its construction, it looks like you couldn't possibly use a vacuum cup to pick up that particular product. And so I think because, again, the inexperience of knowledge about vacuum, somebody would say, oh, we can't use vacuum to pick that up. So they automatically go to the mechanical gripper.
Well, I have to be honest, that the very first example you used, a bolt, I'm struggling a little bit in my own mind that how vacuum could be used to pick that up. Help me understand.
Well, what you would probably decide on is using a product that actually creates more vacuum flow than it actually creates vacuum level. And what that means is you're pulling a lot more air into the vacuum stream. And so when you go to pick up the bolt, you're actually not going to use a vacuum cup. You're going to use the vacuum flow of the product and probably design a vacuum head that allows that flow to be pointed directly at the bolt in this case, which in turn would just pull the bolt up into the flow, and then you could move it and place it.
Okay, so I'm not really, in that particular example anyway, I'm not physically picking up the bolt, but I am getting the job done. The thing I need to get done is to move that bolt from point A to point B. So I'm transferring that, whatever it is. It could be a bolt, probably lots of other things. You could give us more examples, but not necessarily picking it up, but in fact getting moved from A to B, which is that's what we need to get done.
Well, interesting that you mentioned transfer. There is another method in the sense that, maybe I need to move a bunch of bolts and put them in a bag. That's going to get sealed and be put in a box with maybe a product that needs to be assembled with these bolts. And in that case, we use a product that's called a material transfer pump. It is a Venturi, but it functions under the same aspect of vacuum flow, where it will pull all the bolts and nuts and washers or whatever it might be and move them to a spot where it can drop it right into the bag. Bag gets sealed, off it goes.
Off it goes. How about things that are heavy?
Well, heavy is a totally different application in the sense that you need to understand what is also happening with it just because it's heavy. When you're talking heavy products, you want to know what the surface is like. If it's a flat surface, it certainly simplifies the ability to use vacuum cups to pick and place it. The vacuum cups have to be a certain diameter from a holding force standpoint. In the industry, you would want to have a holding force 2 times the weight of the product if you're picking it up horizontally. If you need to grab it vertically, you would probably want to go with a 4 times holding force. So if the product weighed 100 pounds, you would want to make sure your holding force was at least 400 pounds.
Porosity must have an impact on it as well. And maybe that gets back to the vacuum flow that you were talking about earlier. But I can have an object I'm going to pull air through it, for example. Does porous material lend itself to a vacuum application?
Absolutely. There's such a wide range of products out there that have both the ability to create high vacuum as well as high vacuum flow. And so when you have, say, a box, which normally is porous, and you're picking up, say, a box that weighs 100 pounds, then you're going to need a pump that gets high vacuum, say 28 inches of mercury, and also has a high flow capacity to overcome any possible leakage that happens through the porosity of the box.
Now, earlier you mentioned low cost as one of the big pluses of vacuum. In the example we're just talking about, a 100-pound porous box, and I need a pretty hefty amount of airflow to get that. Does that jack the cost up significantly when I need that much?
Not really. What it does do, however, is to create a product that can get high vacuum and high flow, you need to use a lot of compressed air. So therein lies your expense, because compressed air is not cheap. People think because they have a compressor in their building that, well, we can use it and it doesn't cost us anything. But it certainly does cost money to run a compressor. If you're going 24/7,
Right.
it could cost a lot of money.
We talked through an example the other day that I found absolutely fascinating. And I think the category you put it in was fragile or delicate. Talk a little bit about applications when I've got something that I've got to worry about breaking or deforming.
Again, that would depend on, what the product actually is. Let's say it's a cupcake, for instance, and you need to pick it out of a baking pan and put it in a package. It's warm, it's still nice and fresh. You certainly don't want to damage the top of it because then it doesn't look good to the customer.
Right.
So again, you would probably take a product that doesn't create a lot of vacuum so that you're not really, sucking on the top of that muffin, and use a product that has a little bit more vacuum flow that won't be so damaging. And you can use a nice flimsy lipped cup that will flex into any crevices. If you got a muffin that has nuts on the top of it or something, you don't want them being pulled off or
Right.
things of that nature.
There is then a process, I've got to believe, when looking at a specific application. Like, I don't want to pull the walnuts off the top of my muffin. As an engineer, what kind of process would I go through to figure out just exactly how I'm going to solve that one?
Well, it's not really a simple process, but it's a process that every engineer integrator needs to address. One of the first things I would look at myself is say, well, is it porous or is it not? Because if it's porous, you're going to go in one direction. If it's not, You're probably going to go in a different direction. And then you're going to ask, well, how heavy is it? How fast is the robot going to be moving, assuming I'm using a robot? What's the surface like? Is it flat? Is it rippled? There's continuously questions that need to be answered, basically dependent on what the application is going to consist of. Applications can be as simple as a person holding a device that has a vacuum on it to pick and place something from one place to another. It could be more into automation where there's a conveyor, there's a couple robots, and other things that need to be taken into consideration, like electrical sensors to know that I've got the product that I'm picking up and I'm going to move it. Things can get very, very difficult. Things could be very, very easy.
You talked about a little bit the other day, the chicken processing application, and that just struck me as such an interesting one. Can you talk us through that one?
It is interesting because anytime you're talking food processing, you need to be FDA approved. So that changes a lot of things in the materials that you're going to be able to use. In the food industry, you're probably going to have to use stainless steel pumps. You're going to have to use FDA-approved silicone cups if you're using vacuum cups. The chicken application was picking up chicken breasts, and the customer doesn't want the chicken breast to be marked when it's being picked up. So that's something you have to overcome by the ability to adjust the product that you're going to use to pick that chicken breast up. That same customer was also wanting to move chicken nuggets that hadn't been baked yet from one place to another. And so, again, that's a different product, but still needs to be stainless steel. The same process of picking up the chicken breast, they had a water jet cutter to cut all the excess fat around the chicken breast. And they wanted a method of moving that cut off fat to a place where they could dispose of it. So again, you have 3 different applications that are probably going to use 3 different products with the same customer.
It sounds like that's all right on the same assembly line, right? The same process line?
They do use the same assembly line, but they don't do it all at the same time. So the chicken breast and the cutting of the fat off is one process. And then they may do that for 3 or 4 days or a day or 5 hours or whatever it might be. And then they'll change over to do the chicken nuggets.
I got it. I got it. Dr. Vacuum, you mentioned the water jet for cutting just now, and a few minutes ago you mentioned robots. Can you talk a little bit about the integration work and the complementary technologies? Because it sounds like the vacuum technologies that you're so expert at are often, maybe almost always, combined with additional technologies on a line.
That would be true. Especially in today's automation, there are so many things that are added to a process. You have, like you said, the water jet cutter. You have video sensing so that the robot knows exactly where everything is on the line. You have vacuum sensing to know that you have the product. And so you have a robot that does a lot of things, all based on different technologies.
Talk a little bit about, a minute ago you talked about the process, the thinking process one would go through to design an application specifically. How do you go about choosing specific products?
Well, most companies would go to an integrator who has the experience of all kinds of different applications. And they would probably get a lot of that information from the integrator. And again, it could be as simple as a very simple conveyor that's just going to pick up a box and put it on a pallet. Or it could be a very, very intricate application where they're picking up all kinds of different products that are going to go in the same box. They have different sizes and shapes. And so now the integrator is going to have to make decisions on the different types of products he's going to need to do all that on one conveyor. So most customers depend on integrators to solve those problems.
Gotcha. Are there any particular products? I'm sure you do have ones that are your favorites, or give us some thoughts about how to choose the different vacuum products and technologies that are available and why you choose the ones you choose.
Well, I've done hundreds and hundreds and hundreds of applications, from picking up cigars to put in a box, to picking up dog bones to put in bags, to moving all kinds of plastic products, medical filters, medical syringes, IV bags. Just about every industry could use vacuum to solve problems. Interesting ones, I've done a lot of chocolate pick and places, which is really fun to do.
That sounds like a good deal. You get
well, yeah, I get the samples, and when I'm done with them, I get to have them.
That's more fun than the chicken.
Oh, yeah, absolutely.
Is there a particular manufacturer that you're partial to?
Well, I'm kind of partial to the Bimber and IMI Norgren product for a couple of reasons. One, it's high quality. Two, it has a wide range of different products I can choose from. They have a great customer service. And the biggest thing is I can usually get a standard product in 1 to 2 days. So my customer is not waiting at all as well. So that's really why I picked them.
That speed of delivery is a big deal.
Yeah, it certainly is when you have people who are always in a rush. They always want things yesterday.
Yep.
And so the other aspect of the Bimber IMI Norgren product is it is a single stage design product, which doesn't clog, which is a big factor out in the industry.
Got it. That makes sense. Gaze into your crystal ball a little bit, Dr. Vacuum. Over the next 3-5 years, what kind of things do you see coming down the line with regard to vacuum and its applications?
I believe the vacuum is really going to probably take over most of the industry. It is just starting to, it's been going leaps and bounds. I think another thing is everybody's going to be automating. I would say that in the next 5 years, unless you have a very, very niche product, if you're not automating, you probably are going to struggle to stay in business.
Yeah, it'd be hard to argue with that.
Now, when I talk about automation, it doesn't need to always be, a massive robot with all this technology and so on. I mean, it could be a simple application where, you start slow by just getting a vacuum tool, put it on a gantry, pick things up and move them slowly, and then work your way up to maybe more of a intricate type process. But as long as you're headed in that direction, I would believe that you'll be successful.
So crawl before you walk and walk before you run. That's time-tested advice.
Well, what I find out in the industry is people, for some reason, tend to purchase their robot first and then go to designing a vacuum tool to go on the robot after.
Sounds backwards.
And it is backwards, because what ends up happening is they find out that the tool that they need to build and then the product that they're picking up ends up being more weight than the robot that they purchased can handle.
Yeah, that's a very expensive oops. Well, we're getting real short on time here, Dr. Vacuum. Before I let you go, I want to make sure people know how to get a hold of you and how they can pick your brain a little bit in terms of applications and products and technologies to make sure that they're getting their vacuum applications deployed properly. How do we get a hold of you?
Well, I do have a direct line, and that direct line is 774-324-1214. And you can get a hold of me and chat with me on the phone. And something I'm always happy to do, because it's so much fun, is if you're not sure how to go about picking something up and you're willing to send Dr. Vacuum a sample, he'll be happy to take it in his lab and give a go at it and let you know how he would do it.
You're being too humble now. Tell us about your YouTube presence.
Yeah, there's a bunch of YouTube videos out there that you can see me demonstrating some of the products and really see a lot of different types of applications that can be done with vacuum. So it might give you some ideas of a direction you may want to head in. And again, you could look at the videos and give me a call and ask me questions about it and why we did this or that.
Outstanding. Dr. Vacuum, this has been a fascinating conversation. Thanks a lot for taking the time to share some of your insights and perspectives. We appreciate it.
Todd, you're more than welcome. And anytime you'd like to get back with me, I'll be happy to sit and talk with you.
I've got your number. That wraps today's episode. On behalf of my guest, Dr. Vacuum, and our sponsor, the Knott's Company, I'm Todd Youngblood. Talk to you again soon.